Hello, everybody, and welcome to SurrealDB stream number 10. We can't believe that we have managed to get to number 10. We've got some party music still going on. It's been a busy time, obviously, over the last few months. We've been sharing our JavaScript library, full text search indexing, Python, record IDs, SurrealQL. And so as ever, please share where you are watching in from. We always love to hear. And whilst you're typing away, a few reminders. We encourage you to share any comments or ask any questions via the live chat. We're obviously going out to LinkedIn, Twitter, and YouTube as well. So this week, you might have seen that we announced our SurrealDB World Conference winners, our 3 winners, and talking about the conference, we're working really hard to make this absolutely awesome. September the 13th, live in London. It's for the launch of our version 1. We are expecting 2,000 of you to join us live online on our platform. And nearly all of our team, which is now up to 22 people, is going to be flying over as well for the in-person conference in London. We're expecting about 300 live in London as well. So keep your eyes peeled for more announcements coming soon. You can see the link there. Do sign up. It's going to be really, really exciting. As well as that, we've had 3 awesome articles written about us recently. Bowhurst listed us as one of the top 15 SaaS companies in the UK, one of the top 5 startups to watch as well, the biggest one for us. The state of databases, we were listed as in the 80% of people either are already using or want to use SurrealDB. So again, thanks to our amazing community. And then as well, listed as one of the European open source startups to watch. So it's a super exciting time. Today, we are coming out to live to you and we are chatting about record IDs, expressions, and graph queries. We are joined by the wonderful Misha, one of our software engineers, Alexander, our data evangelist, and of course, our co-founder and CEO, Toby. So welcome.
Hey, Lizzie. Well, thank you for that intro. Yeah, really exciting times at the moment, and lots going on. Shout out to Jenna here from Colombia. Welcome. Great to have you on the stream. Anybody else? Let us know where you're from. Let us know if you've got any questions as usual. But yeah, as Lizzie said, today we're going to be looking at record IDs and the magic that they can enable in your applications or in your data analytics, alongside expressions, record links and record pointers and expressions, and then graph queries with those expressions as well. So yeah, Alexander, Misha, great to have you here.
Yeah, thank you.
I guess just a few more shout outs here. Frederick from Spain, welcome. Alpazlan from Poland, great to have you here as well. Yeah, excellent. Well, I mean, I guess where do we start, right? SurrealQL it's powerful. The record ID is one of the magic ingredients that makes SurrealQL so powerful in what you can do, and it's the ingredient that enables time series and graph and CRUD, but also just your general document updates. So, Alexander, where should we start with record IDs and
absolutely. I will just kind of like share my screen a little bit, and we can kind of like go through a little bit of journey. So far, we have touched on record IDs before. We have written this article, we've had a live stream, and we've had a lot of documentation around it. And just to kind of like recap quickly on record IDs and kind of like why they're so magical is in a sense of like when you have different database models, you have like relational, document, and you have graph. What essentially the question is like, what enables us to have these models as a unified thing? And record IDs is kind of like the foundation of it. And to kind of like share more briefly in kind of like more practical examples of that. So we've touched on on like how they look and feel and all these type of things, and encourage you to kind of like catch up on that. But we have recently released some practical examples that you can play with. So you could navigate to our docs, SerealQL and demo, where we recently released some demo data that you can play around with. And here you can see kind of like how we use things for, instead of using joins, we have like the record links and the graphs, which we'll explore in a bit. And this is ready for you to kind of like download and play with. It's very simple to get up and started. You just download the data set. It probably goes to your download folder. Then you simply just have to start up your server and then input the data set. And it will take a few seconds to load in. And then kind of once you...
Awesome. That's really awesome.
Yeah. So once you've got that loaded in, and please tell me if this is big enough, we can kind of like start to see how we actually use them. So a typical SQL query might look something like this, where you're selecting star from a table, and then you're saying where ID equals an ID. And here we can see our first example of a record ID, where you have the table, the artist, and then you have this kind of unique string. And this unique string is enabled by default, as we'll see a bit when we go to the read function. So I kind of included a little bit of explanations on how you read it, how your graphs create, update, and delete. And if there are questions at any point, we'll jump off as we do always. But just wanted to show a little bit about that you have the record IDs in a typical way, but then you can also have them in this kind of like shortcut kind of way. And as you can see here in the pane, it is the same output that you get, but the kind of like performance might be a bit different. And one of the magic that is enabled by the record ID is that you don't have to do table scans. You kind of jump directly to the record, which enables you to do things a lot faster. But we also have another syntax, which is slightly different, where you can actually return something. So here we're returning a record ID, and we're selecting everything from it. And we're getting as well records from it. But you could also select, just say, the address, and you'll get the address. And that's the same for all of this here.
Yeah, so just jumping in there to have a look at the line 2, where you've got where ID equals artist, and then the difference between a line 4. So record IDs in SerealDB do not need to be written in strings inside quotes or double quote marks. A record ID stands alone. The only reason we support record IDs within strings and why we parse them as such is because of JSON. So when you're working with JavaScript or TypeScript or Golang, a library which serializes data to JSON before it sends it to the server, then we have to be able to parse it in such a way. But behind the scenes, we're not storing that in JSON, and you don't have to write it in JSON. And actually, if you're using the command line integration with SerealQL, then you can actually format that as SerealQL, which means your record IDs will be formatted as you see on the left on row 4 and 6. So yeah, brilliant. Thanks for that, Alexander.
Yeah, no, absolutely. And so we have here on line 8, we're selecting star from order. And just as a side note from here, we have, of course, in SerealDB, the concept of a schemaless and a schema-full table. And here, the artist is schemaless, but the order is schema-full. And we'll get a little bit to the definition a little bit later, but that will be important in a bit. But you can see here everything from the order, and you'll see here the ID is a little bit different. And this is what's called a complex record ID, where you can have an array of elements in this array. And the way you would select from this complex record ID is effectively putting the array after the table name. So you can select, here we have England and the time. But you also have something called range queries, which are very important for time series. And that is as simple as adding those two magical dots here, and then you get a bunch more stuff. So here we have 8,082 rows. So we're selecting everything after this date. And if we take it away, we only get one row. So those make it relatively easy to work with time series data as well.
Awesome. I'm just going to share my screen and show a few other things related to this. So here's an example of just kind of the many different ways that we can parse IDs. So as Alexander's just gone through, we can specify an exact record ID. Here we go, person test in the first line. But if you, for instance, have traditional data where your ID is just a number or just a string, then we'll also parse that according to the table that you are inserting it into and create that record ID on the fly. So there are many ways of creating these record IDs, but ultimately at the end of the day, every single ID in SurrealDB is always going to be in a SurrealDB record ID format. And that is what enables all the amazing functionality that we're going to be talking about in today's stream. So, Alex, I'll take it back to your screen there.
Yeah,
awesome.
Absolutely. And just kind of like showing practically what you talked about creating record IDs. So we have the default here. So we're creating an artist and we're getting the ID of the artist with his kind of unique record ID. But we have options for selecting different things. So here on line 3, we are creating artist with a UUID. And as you can see here, we have a UUID for the artist. One thing to note is you'll see these kind of like special brackets around the UUID. And then
we've got a request before you carry on. We've got a request from YouTube, Alexander, for if you could zoom in the screen a little bit.
Sure. Let's see.
There you go.
That's better. Okay.
We need a way in the future to zoom in the code rather than the entire screen, don't we? That would be good.
Yeah, that is. All right. I hope that is better. So we have the UUID. We also have an option for ULIDs if you want to create those. We have an option for creating an artist, Bob, or let me just say Jane at the moment, because I think I might have. So here we see Bob record. Bob already exists because I ran that query. Let me just see here, Jane, and let me just do 2. Very good. Cool. So now you can see that you have an artist with a string, and then you have an artist with a number. Now, when it comes to kind of like best practices and all these kinds of things, ideally you wouldn't want your ID to have meaning. So that's why we have the default to be a kind of unique ID, because that helps with when you're working with like distributed systems. It helps with making sure you're not having accidental data leaks and all these kinds of things you need to think about in a production setting. And that's also why we offer simple ways of using UUIDs and ULIDs. There are, however, use cases where you want to have, say, a string or a number. So that is also an option. And then the way you would create the complex record ID is effectively having this array and kind of like what you want to put into the array. So here we're essentially selecting the current time which we put into the array. And now we come to the kind of like schemaless versus schema full. So with the artist is schemaless, so it doesn't matter what I input, it will accept everything. But when now I want to just create an order England and time now, it will give me this error saying that, oh, it is not conforming to the schema. And we have defined kind of the schema here. And let me just zoom in on this quite a lot. So we're defining the table order, and we're saying in schema full, we're defining the types and all the fields and their type that they should be. And if it doesn't conform to that, just like in a kind of like more relational database style, you'll get an error that it doesn't conform to the schema, and that's what we're getting here. So that's why if we want to create records in the database, we actually need to have something that conforms to the schema like so, and then we can create it. All right.
That's awesome.
Moving on, we have we can update selecting only a record ID, and this will like perform a very atomic update. You don't have to do this kind of like scan or whatnot. And here we can see we have the more stuff, and then delete would be the same. Now noting that we don't get any results returned when we're deleting something. And then the last two things I wanted to mention are the links and the graphs. And those are kind of one very core thing when we think about how we do kind of like connecting data together without using joins. And so here we have a table called review, and I'll just bring up the graph a little bit here. So we have this review table, and this review table is connected to the person, the product, and the artist. And if I select from the review table, we can actually see what the review table is made up of. So you have the ID for the review table itself, but you also have an ID for the artist, and you have an ID for the person, ID for a product, and you have like a rating and the content of that ID table. Now, this is essentially what allows us to kind of like jump a little bit. So here in our second query on line 3, we are selecting everything from the artist table, but we're actually selecting it from the review table, and we're selecting from a specific record in the review table. And as you can see here, even though I'm selecting from the review table, I'm actually getting everything from the artist table. And the reason for that is I'm kind of like going through the record. So I'm essentially going here, searching in the artist record, and then I'm taking everything from that record. And so that can actually kind of like, as you see on the picture, I'm essentially going through the link to get it.
I think that's the biggest difference, isn't it? In other databases, relational databases or document databases, you're thinking about data in terms of collections or tables, and in your mind you're thinking about it in terms of spreadsheets. And you can still do that in SurrealDB. It's not a graph which is described with metadata. You can still think in terms of tables or collections, but you can think in a more connected way. All of your data relates to other fields, other tables, other records, and because of that, it enables you to kind of describe and understand your data in a very, I don't know, in my opinion, it's an improved way. It enables a better way of understanding or reasoning about your data. But I think that's the biggest takeaway. And just to shout out again, to Alexander for that demo data set. It's really awesome. You can now get going with a large amount of data in Surreal, working with the graphs, with the time series, with aggregate views, and we'll be improving the way you can import this into the database and into the playground in due course as well. Before we carry on, I've got a question here I've got a couple of questions. The first question is probably aimed at Misha, given that Misha opened an issue for this on GitHub. It's is it possible to enforce some fields, but beyond them allow anything else as well? So kind of a hybrid between schemaless and schema full. So I guess that's actually linked in two different questions. You've got the fact that you can do schema-less tables with schema-full fields, and you've also got the fact you can do schema-full tables with schema-less or flexible fields. So yeah, Misha or Alexander, how about that?
Yeah. So since Beta 9, I believe it's possible to create, for example, a field with a flexible object, and what that means is that field it must be an object, but any of the nested properties can be anything really. So there's no schema enforcement there. we are looking into ways to improve typing to sort of extend this feature, make it even more powerful. A bit like, how do you explain that? For example, within TypeScript, you've got the possibility to have a type where you got like a common key, and depending on the value of that key, the one type will be enforced or the other type will be enforced. So that will be a cool feature. But the other way around, when you would have like a schemaless table, as Toby mentioned, you can define certain fields on it, which are schema full. So that kind of gets the result that you're looking for, I think.
Yeah, I think absolutely, and that's a practical example of that. We have an example of that in a demo data set here, where in the schema-full table orders, we have a shipping address that is defined as a flexible type of an object, and so now we can, like, all of those all of the fields besides shipping address are strictly defined. But like Toby mentioned and Misha mentioned, when we're inputting the shipping address, which is a field that is nested. So let's just go select shipping address from order. We can see that field is nested here. And in the definition, I didn't define address line 1, 2, 3 coordinates or country. It just accepts everything that is under shipping address.
Yeah, that's really great. I think it's important to note where this is or can be of interest. A really important use case is for logging. You always have certain fields that are always seen in every single log, but you may have some JSON data or some arbitrary data that is different for every single log, and therefore you, as much as you want to make that table completely schema full, there's just no way of doing that and at the same time storing data. So you could either make your entire table completely schemaless and have certain schema-full fields that are always existing or always of a certain type, or you could go the other way around and say it's a schema-full table, but this particular field, maybe it's log data, is completely schemaless and it can accept any content within it that I choose. We've got another question I'll bring up here from Zafar. So 1 to 2 many relationship with record links is not a viable efficient, and it's an issue. So Zafar, yeah, this is your related to your GitHub issue on GitHub. We're looking at ways that we can improve the efficiency. Record links within documents they're not designed to have thousands. Obviously, you're supposed to move to graph edges, which we'll talk about a little bit more, and we'll look at the demo data set with that as well. Your suggestion online of creating a new type which isn't stored in the document and is stored separate from the document is one route for going this. So yeah, we're definitely looking at this, making it efficient when you have large numbers of record links. But even if you've got a good number of record links, it should still be performant within the documents themselves at the moment. So Alexander, where do we go from here?
Yeah, I think we can just start from the point that was mentioned about like record links and graphs. So we have, just wanted to show you here, we have, of course, the review table. We're selecting artists from a review table over here, but then we are selecting just directly from the artist. And I just wanted to kind of like bring home that point that if we look at the artist table, there is no link to the review table. And so we have linking from the review table to the artist right here, but we don't have linking from the artist to the review. And that's kind of what Toby mentioned about like one-way linking. So you have the review is linking to the person, but the person is not linking to the review. Now the difference here is the graphs. So if you notice, the arrow is pointing from the review to the person, but in the graph there is no pointing because it is bidirectional. So the order is linked to the person and the person is linked to the order. and we
That
kind
was
of can
actually
see that.
an interesting question I saw pop up on Discord or GitHub recently, which was, how do I make a bidirectional graph? And actually, all of our graph edges are pointing in a single direction, but can be traversed bidirectionally, and that's something important to note.
Oh, yeah, absolutely. So if we look at, maybe we can look at the docs simply for that. So there's, of course, the question of how these are different, and we have docs about that kind of explain that in more detail in terms of like what relate tables are and how they're different from other tables, and kind of like what's the difference between a graph and the record links. Now the record links again offer just one direction, whereas graphs offer bidirection by default. There's also the concept of referential integrity, which is can be quite important, and some people are surprised that you can create record links that don't link to anywhere, but you can't create a graph that doesn't link to anywhere. And so that's an important concept here.
A very big difference, isn't it? So yeah, when you write a record link, you can point to something that doesn't necessarily exist yet, or maybe existed but it's been deleted. And we've got some ideas on how to improve that down the line. But if you do want to have that integrity between your relationships and your data, then switching or moving to graph edges for that functionality is definitely the way to go.
Yep. And just as a simple example for a kind of like graph, you have the kind of like graph table has three kind of fields that you have by default. You have an in, an out, and an ID. And we have different syntax for selecting it. So you can select from road, you can select in, or you can select person. So there is different syntax on how it works, and this article goes into some detail on that, but we can see from the demo data set how it could work. So here we are selecting from person, and if we go back to the picture, you can see that the person is kind of feeding into the order. So that would essentially, when you're creating it, that would be the direction. So the person, order, product. And so because the person is essentially feeding in, you can select everything like so, which would be the same as like so, or not quite. So you can see that here.
I mean,
So
just to describe what exactly is happening here, because I think a lot of people don't necessarily realize what is happening. This is actually traversing from the person table directly to the orders table, and you can pull in any data that you want. You can even traverse more tables deep, but this is effectively the same as pulling your data down and then pulling more data down and linking it on your local development machine, or doing a join in relational database terms. So the simplicity of this query really is quite amazing, especially when you're doing more than 2 tables deep.
Yeah, absolutely. And we often get the kind of like, people are often scared by graphs, but it's only because people might be very familiar with joins. But there is so much more potential for things going wrong with joins, because you have to kind of like keep things in your head all the times in terms of like, okay, does this link to that? Okay, or what level is this on? And like, do I need like 3, 5, 6, 7, 8 joins? And all these kinds of things. Whereas for here, we didn't actually have to specify join keys. We didn't actually have to specify which granularity it is on, and so forth and so forth. And so it really makes things more simple, even though it can take a little bit of time getting used to.
Before you go on there, Alexander, I've got a question here from Marcin. Are you aware of any tool for schema migrations for schemaful tables being already created for SterilDB? I'll let you two answer that, but there is a great tool, if I'm correct in thinking, for doing exactly this already existing, isn't there?
Yeah. Misha,
Yes,
do you
this
want
is
to take this?
Cerulean Migrations by O'Donnell, one of our community members. I will link it real quick in the chat.
Okay, brilliant. I'll bring it up.
It's a Rust project, I believe.
One second.
Yeah, like here.
There you go. So this is the link to the migration tool. As Misha said, this can be used. It's an amazing project. You can use it within Rust, within GitHub Actions, or just locally as well in the command line. You can effectively move your schemas between different databases so that you've got development databases, testing databases, production databases as well. What's the other functionality it's got, Misha?
I believe that he's working on stuff like branching, backward migrations, and some other pretty neat stuff. I haven't really looked into those different features as much as I want to, but there's some really great stuff out there.
Awesome. And I think down the line, data branching as well is a feature intended, isn't it?
Yeah. He's already talking about it. It might actually. It looks like it already exists in some form. Looking at the README.
Awesome. So yeah, so that is that's a great tool there, Martin, for migrating your schemas and potentially data, but at the moment schemas between one database to another and upgrading those as you go along. And you can put all of those changes into version control and have it run within GitHub Actions as well. So really great way of managing your database. We've got another question here from Papa Megamind to do with transactions coming to the Rust wrapper, so not necessarily to do with record IDs. But just to answer this question, this is going to be a feature that we are looking to add in. So at the moment, transactions have to happen in a single write on the database, atomically, as it were. So you have to push your whole transaction with the begin and the commit part of the transaction as one with any statements you want inside those statements. We are looking to bring that forward to the client so that you can actually start a transaction in the client, run your own business logic, and then bring that data, commit that transaction or cancel that transaction based on data that you pull down from the database. So that, if you're looking for that particular functionality at the moment, that's not possible, but we do have that on our roadmap. So it's coming soon. Excellent. Let's jump back into record IDs and touch on looking more at the graph.
Yep.
There you go.
So here we're at the moment where we're looking, essentially selecting everything from the orders table. So this table is kind of like the middle table, and it's kind of like the connecting table. But we can also do more things. So we can either select the in table, which would be the persons, and I'll show you in a bit how this works. So here, what it's actually doing is selecting the record IDs, and to effectively get what's inside of them, we can actually do this. We're doing that, but there is another way of also doing it where we can see. Let me just see here. Person. So this would be the equivalent way of doing it. Now, I did this relatively fast, and you might not have kind of like been aware of what was happening. So let me kind of like show you what was happening on the schema here. So what I effectively did was selecting first everything from this order table, this middle table here, and then I went into this person table. But since the kind of like edge table here is just made up of in and out, so we have the in, which is a person, and we can do dot notation, so dot in to get it, but we can also do the graph notation to get it. And so that's effectively what I was doing. And so here we have the graph notation. And if we don't do this dot star, we're just selecting the record IDs. But if we want to select what's in those record IDs, we can do the dot star to get the contents. And that's the same.
Vice versa, we can also just put a particular field or particular. We could get all the addresses, for instance, from the people who have made the orders.
Yeah, absolutely. So here you can see just all the addresses. And the same is for the opposite. So here, because we're starting from the order table, and the reason why we are doing this back arrow is because, and this is better shown here, is because we're going back to the person. So we're starting from the orders table, and then we're going back to the person. Now, if we're going forward to the product, because our definition was person, order, product, then we would go the other direction. So let me just show you that. So then we do product. And because we want to see all the products, all the content from the products, you can see that here. And you can see here that we have this kind of like syntax that you go order and then product. To get rid of that, we can just do an alias. Like so.
Yeah.
And that would be this.
We've got a point on our internal communication channel here at CerealDB to do with how, from Hugh actually, to do with how bidirectional relations maybe are not necessarily the same in traversal mode as they are in insertion mode, and the other way around. And that's probably a point to touch on, actually, because we've had that question a couple of times on GitHub and on Discord, and how do we create a bidirectional link or edge between two nodes? Now, when you create an edge between a node, it's always one way. So if that person bought the product, then those two edges are always pointing out. And if the product was bought by a person, then that's always going a single way as well. We made a decision not to, it may be something we change in the future, we made a decision not to create bidirectional links themselves because this would then reduce the performance of how edges work in the database. But when you traverse these links, you can traverse them in a bidirectional way. Now, and this is where Hugh's point is important. It depends on your concept of what you're creating as a developer. If you're creating a link that is bidirectional, i.e., it has no meaning of the direction, then traversing it is no issue. I guess that comes back to what is the meaning you put on the links between those nodes, and does the direction matter? If it doesn't, then traversing it bidirectionally is not a problem. If it does matter, then obviously if you traverse that bidirectionally, it has a meaning. So it's probably better to, in that case, if you do have bidirectional links between records, or the direction actually matters, to actually traverse those separately, both as outs and ins to a particular record. Alex, sorry for that interlude. I'll let you carry on.
Oh, no worries at all. Just kind of touching on that. So we have in our documentation like example here regarding where a person wrote an article. So when you are creating, like relating the record, like Toby said, you kind of define it in this direction. So it will be like this person wrote this product. And when you're querying it, you kind of just start essentially from here, where it's like person wrote, and then you go either in or then out.
That's brilliant. I'm just going to carry on this because Hughes jumped on our LinkedIn just to say, look, it's also possible to have a record that stores the information and link to it from two relations, depending on the use case as a developer. And this brings us back to another way of building graphs. Is actually on Alexander's screen there, you've got the person record on the left, you've got the article record on the right, and you've got the wrote record, which is the verb, and that is the edge. and that will get its own ID, as you can see there, random ID. But that record itself is just a normal record in a table. So although it is an edge, you can also, as you said, have things pointing, have two separate links between person and article, both going in each separate way. But you could also link to a node in the middle, whether that is another noun, or let's say there's a relationship node and the person has relationship and another person has relationship. But also in SerilDB, you can actually link to the rote node itself, which means the edge can also then become the node, if that's what you want to do. It's probably not advisable because then you're mixing up nouns and verbs, which is traditionally how you'd think about a graph, but it is possible. So yeah, Hugh, thank you for that.
Yeah, and also to, I guess, point out, because we have this ID here, you could use that as a record link as well.
Exactly.
So I guess kind of like the point that we're often discussing is in terms of you have so much flexibility in the way how you're doing things, and oftentimes you have other databases that are very kind of like there is only one correct way, like the way I do things, and like very, very restrictive. Like, for example, you have SQL, like you either do auto increment or you do UUIDs. Like there is, like, that's it. That's your choices. And so when you have all this flexibility, it's also just being aware of like what are the use cases for each and what are kind of like the problems you might encounter. And that's definitely something we'll produce more content on.
Absolutely. I'm just going to bring up my screen for one last slide, which is this is on the website on the features page, I think. But this is an example of really the power and the flexibility that you can use in SerilDB. So this is mixing up record IDs. You see the person Toby there, and then it's using graph edges. So who does he know? This is the first example. So who does he know? And we'll group that as the F1, the first result. And then who do they know? And that's F2. And then we want to find out who they know or like, but actually we want to filter on that and then get those connections. So it's really powerful, and you can traverse and filter. You can work back towards a node, out from a particular node. You can work out from an entire table. It's always better if you try to kind of center your relation onto a particular record or a particular set of records rather than an entire table. You're going to get the best performance that way. But some really advanced things that you can do with SerilQL and the graph and record IDs. I guess we're almost at the end. There's so much to talk about here. I guess. What are your, Alexander, Misha, anything we've missed that we can touch on in a future stream, or anything that you think is really powerful about, maybe that you haven't touched on, about the record IDs and the record links and the graph edges?
So there is an example that I can craft up real quick, which is to do with mostly time series data. Let me see. So if you could pull up my screen, there we go. So let's say that.
Can you just make
it bigger, Misha? Make it much bigger.
I'll do
there
that.
You go.
There we go. It should be good. So let's say that we've got a table demo which is schema full, and we've got a field date on there on demo. But let's say that that this is a time series table essentially. So we are storing the date inside of the record ID. What you can do is you can actually grab that value from the ID field, and let's say that we also have some other data. So we have something on demo, which also grabs something from the ID. We can create a demo with the current time and something. And as you can see, can see that the date now gets grabbed from the ID, so it will be the same actual value, and we'll put it inside of a different field. And we're using this for some projects, and it's a pretty powerful feature.
That's awesome, and that actually links back to the range queries that Alexander was talking about earlier, because then you'll be able to range query only over certain records that maybe match a particular date or from a particular location. Before we go, I've got a couple of questions here. So Alice has said, I still struggle to think of data to put into edge tables. It's a really interesting question, especially when you come from, or if you come from a relational or a document database perspective. So if think of the edge, so you've got two nodes and you've got the edge, and the edge is always described as the verb. So if you think of the data that you might want to have on that particular verb, maybe it's the date that the relationship was started or the date that the product was purchased. So maybe it was the price of the purchase between a person and an order or an item. So the person ordered an item, the order has the information about the price, the currency, the time, and everything like that. So do you have any other better examples, either of you, on terms of what data you might put on the graph edge?
Yeah, so I guess the two examples we have is the one you took, which is essentially the approach we took from the demo data set, which we have, of course, product information and we have a person information. But we all have the order table, which is kind of like the edge table that combines the two, because the person orders a product, and so you have like the combination of all of that in a products table, in an order table, I mean. But in the docs, we also have the example of a person wrote an article, and we have information of, okay, when did you write the article? Like, do you put that in the person table or the article table? Well, you can actually put that in the row table. So the row table has a timestamp of when the person wrote it. And you can have other stuff that is related to that. And so it is in a way of making sure that your data kind of tables are clean and kind of like focus on the subject matter. So the person table contains information about the person. The product or article table contains information about the product or article, but then the information that relates to both of them can be in that kind of joint table, whether it's orders or wrote or any other kind of connection.
That's an awesome way of putting it. I think we're coming up to the end of the stream, so I'd answer a couple more questions. Orthodox Forever will definitely consider making a stream about geospatial possibilities of the SerilDB. We never really thought of that as a separate topic, but absolutely we'll look into adding that in the future. But in the meantime, if you want to get started, then jump into the documentation. There's some good examples on the types, the geospatial type page, and also then the functionality around the geospatial search and distance functions. So yeah, so jump on there, jump on our Discord if you've got questions as well. I'll put the link in the chat just quickly. If anybody isn't on our Discord already, then that is the link. You can go straight to our website, go to Discord, and jump in. We're always on there answering as many questions as we can. Also, shout out to the community, amazing community, answering back questions and supporting other users all the time. So yeah, jump on there if you've got questions about geometric functionality, and we'll get that into a stream in the future. Anything else I've missed? There you go. There's a conversation going on YouTube and LinkedIn now. Nothing I've missed. So yeah, Kings of Slow-Mo. If you this stream will be recorded and on YouTube, so you should be able to see this afterwards. So excellent. Anything that we've missed, Misha and Alexander? Anything at all?
Well, I think just that it might not be missed, but there are more things coming soon. So I'm sure we'll have more things to share later.
Absolutely, some great functionality being worked on by the entire team. And for those of you who haven't seen the announcement on Discord, we've got beta 10 release coming very soon. We're just trying to work out some of the complexities around the storage format, so that this release is backwards or forwards compatible with the version 1 release in September, so that you won't have to upgrade or export your data to move on to that release. So coming really soon. We're just trying to work out that last piece of the puzzle. Other than that, just one final reminder: we've got our Cerulean World Conference in September. It's being streamed online and in London. It's free to attend. So if you're in London on September the 13th, do come along. We've got some exciting announcements, some new things that we haven't yet discussed or spoken about, and we'd love to see you all there. Other than that, Alexander, Misha, Lizzie, thank you. And thank you to everyone for watching. And we'll see you either on Discord stage or on this stream again in a few weeks' time. But thank you, and enjoy the rest of the week.
Thank you.